Alright, here we go. I don't know how this is going to work, but we'll find out. Alright, so this is problem number 1 from the homework. um, Again, I apologize for today. That was a brain fart of epic proportions, and yeah. Alright, so when we're doing these problems, the first thing you need to, the overarching goal is to find an x bar, right? So x bar we know is, as we discussed in class, it's going to be the integral of our x of the centroid times the derivative of the area over the integral of the derived area. So the derived area is, well, as we were talking about, it's these rectangles that we use to determine the area under a curve, right? So there's a bunch of little rectangles here. So each one of these represents a dA. So just for simplicity terms, and because that's how we're going to solve the problem, we're just going to look at one of these, okay? So let's just look at this one. Alright, so since this is x bar, y bar is just going to be the same except with y. You're going to have the integral of your y centroid derivative of area over the integral dA, right? So these are the two equations that are probably the most important for this whole problem. What we're going to do in order to break it down into more steps is we're going to focus on just the top half of both of these equations, okay? Because we can solve for the bottom half pretty easily, which we already did, but we'll do it again. So if we're looking at, let's just blow up this rectangle real quick so we can see what's going on here. All right, so what we're going to call this is our change in x, dx, right? Because over here you have your x-axis. Basically, we're just looking for this little portion, dx, that's changing, right? Because we're going to make several little dx's in order to find the integral. Excuse me. And then, as we said in class, we're going to call this y. Just arbitrary values for now. All right, so let's go at it. We'll use red. So the first thing, like we said, is we're going to solve for dA, which is the area within, oh, my computer just went dark, I hope you can still see me, within the rectangles that we've created, right? So there we go. As we said, it's just going to be base times height, which is going to be our y times dx, right? So dA is equal to y times dx, all right? So if we wanted to solve for a, we would just integrate that equation, y dx, right? And we're going to do it from 1 to 2 because that was our shaded region. I know I didn't draw that on here, but if you look at your homework problem, this whole region is shaded, right? So that's the area we're going to integrate from. We're going to integrate from 1 to 2 in terms of x. So if we do this, we're going to plug in, hopefully I'm not going off the screen, we're going to plug in our y equation. We've got 1 plus 1 plus x cubed over 8, and we're going to multiply, we're integrating this with respect to dx from 1 to 2, okay? So this equals x plus x to the 4th over 4 times 8 is 32. We're going to do that from 1 to 2. If you solve this out, you end up with 47 over 32. Hopefully you guys can read that. I'm sorry if you can't. So we end up with 47 over 32. So this number right here represents our area, right? So what we're going to end up doing is when we plug this into these formulas, this is basically going to be your denominator. Okay. All right, so moving on, let's figure out the top half. So we've done the bottom half, let's do the top half. So the top half of either one of these equations is the integral of your x-centered times the derived area, right? So it's weird to say right because you guys aren't actually here. Alright, so this is where we got confused in class. So let's take a look at this in greater detail. XC is the distance, and this is what I was unsure about after clarifying it with Professor Stokes. XC is going to be your distance to the center. So you have some center of gravity here. I usually denote it with the funky little sign. You have some distance here, which you're calling XC, and then you've got some distance here, which you're calling YC. So these are the distances to the center of gravity of your derived area, right? So you've taken this block, you blow it up, so the distance from the origin, point O, to the center of your area is going to be XC, comma YC, right? So XC in this case is going to be, weird to ask you a question because you're not here, but it's just going to be X, right? Because it's arbitrary depending on where you take your rectangle to be. So XC is just going to be X in this case. You can leave it as XC, but in order for your equation to work out, you're going to need to label it as X because that's how you plug it into the formula, right? So if we plug this in, we know dA was y dx, right? Or in other words, this thing, where'd it go? Yeah. We know that. So we're going to carry this through. It's going to be the integral of x times dA, which we said was y dx. And we can even take it one step further, plug in y, so you know that, am I going off the screen yet? No. So we've got the integral of x times 1 plus x cubed over 8 dx, right? So then we're going to distribute the x. You end up with x plus x to the 4th over 8. You're going to integrate this, and where are you going to integrate it with respect to? Well, it's in terms of x, and your area is from 1 to 2, so same thing goes from before. It's going to be from 1 to 2 with respect to x. You solve this through, you end up with x squared over 2 plus x to the 5th over 40, right? 8 times 5 is 40. And you're going to do that from 1 to 2. And that turns out to be 91 over 40. So this term is going to go up here. So if we wanted to solve for x bar right now, we could. So let's go ahead and do that. So we plug in our values here. We've got 91 over 40 over 47 over 32. And if we plug that into our calculator, we should end up with 1.549. And that is your, they didn't specify your units of measurement, so you don't have any. So that is your x bar distance. Excuse me. I would recommend, if you don't have this down, pausing, because I'm going to erase it and start for y bar now. So let's go ahead and I'm going to make some room here. Alright, so y bar. So same thing, we're just going to focus, we already know the bottom term, right? It was the 47 over 32. That's just the integral of dA, which we solved for. So now we just need to solve for this top term. So the integral of yc dA. Alright, so let's look at this. So our block here, our yc is the distance from the origin plane, right, the x-axis, to the center of gravity of our area. So that would be yc in this case. So if we look at this, y is the total distance from the origin to the top of the shape. But the center of gravity is in the center. This is where we also got confused in class, so I'm just going to try to clarify it. So yc is the distance from the origin plane, the x-axis, to the center of gravity of the shape, which is, in this case, going to be yc over, or it'd be, so they tell us that this distance here is y. So our yc is going to equal y over 2, right? So we knew that xc is just going to equal x because that's the distance that we've gone, and yc is going to be y over 2 because it's halfway of the height of the area that we are using. Alright, so let's go through this. So we know yc is y over 2. We know at dA, well, I shouldn't have erased that, but dA equals what again? It was y dx, right? So we can plug in all of this stuff. So yc we said was y over 2. And then we're going to multiply that by our dA, which we said was y dx. And then we can plug in our y term, right? So just, I don't like red, sorry. We're going to go back to blue. So if we pull out the 1/2, simplify things up, then we have y times y dx. So then y squared dx, 1/2 integral of y squared dx. We know what y is from this equation, so let's plug this in. We've got 1/2, so 1/2 times the integral of 1 plus x cubed over 8, and that's squared with respect to x. And we're going to integrate this again because we put everything in terms of x. So let's look at our boundaries, which is 1 to 2 again. So if we integrate this out, you're going to have to do some math here. Let's look at this. We're going to go, I'm getting kind of low here. 1 plus x cubed over 8 times 1 plus x cubed over 8. With respect to x. So then we do some distribution, or we have to integrate it first. So this would turn out to be x plus x to the 4th over 32 times x plus x to the 4th over 32. So then we distribute that. You should end up with the, let's see, you're going to have, gosh, x squared, I should have distributed this first. Let's go back. Let's distribute this a little more. Let's turn this into a polynomial. So if we do this, remember the 1/2 out here. This turns into, let's see, it'd be 1 plus x cubed over 8. It'd be 8 over 2 is 4. Let's see, plus, gosh, I wish you guys were here to help me. X to the 6th x to the 6th over 64. 8 times 8, yeah, 64. Check me on that. I mean, I think it's right. Dx. So let's integrate this now from 1 to 2. So that'll be a little easier. We get, remember the 1/2. Gosh darn it, I am not doing very well with carrying this through. So 1/2 times, you're going to have x plus, that would raise to the 4th, divided by 4, you're going to have 16, so x to the 4th over 16. And then raise to the 7th, x to the 7th over 7 times 64 is 448. Okay, and you can integrate all this from 1 to 2. So if you plug that into your calculator, you should end up with 995 over 896. Okay. So then we're going to use this value and plug it in up here. You've got 995 over 896 over 47 over 32. And that turns out to be 0.756. Right? So, and then if you think about it, x bar 1.5, yeah, that's probably somewhere around here. That's probably right. And then y bar 0.756 would be about here. Hey, that's probably right too. When somebody had a question today about why this, let's see, why like this value is going to be greater than the actual distance. That's a good question. It's because basically you've got, what you're doing here is essentially you're summing all of these boxes together. Okay, you're basically taking all these center points here, something like this, right? And you're summing them together, and then once you divide by the area, right, you're summing them together multiplied by the area. So what you're doing is you're taking a weighted average. So when you divide by the area, then you take that average away, and that'll give you your very centroid, I guess, your center of mass, x bar or y bar. If you have any questions, email me. I will, like I said, I owe you guys something, so I'll post something for problem number 2 or 3 tomorrow. All right? All right. Good luck.